Welcome students to today's session. We are going to study the topic graphical representation of motion. Graphs provide a variety of events. To describe the motion of an object, we can use line graphs. In this case, line graphs show dependence of one physical quantity such as distance or velocity on the other quantity such as time. Let us have a look at representation. We are going to first see the distance time graph. In the distance time graph, if there is a line running straight diagonal across the x and the y axis, we have what is called as uniform motion. That means the object is moving or covering equal distance at equal intervals of time. If it is a line running parallel to the x-axis, then we have object at rest. It means that the object is remaining at the same distance with a lapse of time. In the other two cases, the object is moving or covering unequal distance at equal intervals of time. This is how we read the distance time graph. Is going to be velocity time graph, where velocity is taken in the y-axis and time is taken in the x-axis. Then the first graph reads uniform acceleration, whereas the second graph, where a line is lying parallel to the x-axis, it is uniform speed. The third graph, it is uniform retardation or deceleration. And the fourth graph gives us non-uniform acceleration. So this is how we read distance time and velocity time graphs. Now let us study detailed graphical representation of motion. Let us first consider uniform motion. We will see distance time graph and uniform speed. We'll take time in the x-axis and distance in the y-axis. This is called as the slope of the graph. The slope of the distance time graph indicates speed. Speed is equal to, or slope of the graph is equal to AB by OB. The triangle ABO. If it is velocity time graph with uniform speed, then you will find the line running parallel to the x-axis. Now the area covered under the graph between point B and C at time t1 and t2 gives you the distance travelled. Always remember, area covered under the graph for a speed time or velocity time graph. Here it is, the area covered is a square. ADCB between time t1 and t2. The area covered under the graph gives you the distance travelled between time t1 and t2. Let us look into the velocity time graph where uniform acceleration takes place. We'll take velocity in the y-axis and time in the x-axis. Now here, the slope of the graph OA is given by AB by OB. But here, the slope of a velocity time graph indicates acceleration. In the distance time graph, it was speed or velocity, whereas in velocity time graph, the slope of the graph indicates acceleration. The area AOB gives the distance traveled. Area covered under a velocity time graph gives you always distance traveled between O and B. Here it is a triangle. Now let us take another graph showing uniform retardation or deceleration from point A to B during time O and B. The slope or of the velocity time graph here indicates retardation or deceleration. The vehicle or the object is coming to rest. Retardation is represented by AO by OB. The area under the graph again gives the distance traveled. Let us look into velocity time graph of uniform acceleration. When speed is not zero, it is starting with c. The initial speed is starting with c. In time from O to B, the slope of the velocity time graph indicates acceleration. Acceleration is AB by OB. Now it is not a triangle, instead it is a trapezium. The area of OCAB gives the distance travelled. It is area under the graph, which is a trapezium. When it is a trapezium, we can make it as a rectangle plus a triangle. Now, based on the different calculations, we have three equations of motion. When an object moves along a straight line with uniform acceleration, its velocity, acceleration, and distance covered are related by these set of equations of motion. The first equation is v is equal to u plus at, where v is final velocity, u is initial velocity, a is acceleration, and t is time. S is equal to ut plus half at square, where s is distance covered, u is initial velocity, t is time taken, a is acceleration, v square minus u square is equal to 2as. In all these quantities, u stands for initial velocity, v is final velocity, a is acceleration, s is distance covered, t is time taken. So these are the set of three equations of motion which has to be remembered. Thank you for listening to today's session.